Let's talk about enantiotopic hydrogens. If a carbon has two hydrogens that is attached to it and also two non-identical groups that's attached to it, then these two hydrogens right here are said to be enantiotopic hydrogens. Remember, the enantiotopic hydrogens are going to be chemically equivalent, meaning that they are going to exhibit as one signal in the NMR spectrum. And when you replace one of these enantiotopic hydrogens with deuterium, then it's going to give rise to a chiral compound, because this carbon will be a chiral center or an asymmetric center. And therefore, this carbon is said to be a prochiral center. And when you replace this hydrogen, the HA hydrogen, with D, then this hydrogen is said to be a pro-R hydrogen because it will lead to the R isomer or configuration product. And similarly, replacing this hydrogen will lead to the S isomer. Okay. Diastereotopic hydrogens. If a carbon has two hydrogens in a compound that has an asymmetric center, then those two hydrogens are said to be diastereotopic hydrogens. And replacing each of the diastereotopic hydrogens by deuterium is going to result in two diastereomers or a pair of diastereomers. Remember, diastereotopic hydrogens are not chemically equivalent and therefore they are going to show up as two separate signals in NMR spectrum. And another thing to note down is the diastereotopic hydrogens are going to react differently with achiral reagents. Say, for example, if you look into this compound, which undergoes an elimination reaction to form the E2-butene, the elimination of HB and Br is going to be much faster than the elimination of HA and Br. Okay? And therefore, you can definitely tell that the diastereotopic hydrogens are not chemically equivalent. And they are going to act differently with achiral reagents. Let's do a simple problem here. And let's see whether we are able to do this problem to find whether these compounds have diastereotopic or enantiotopic hydrogens. Okay, let's take the first compound. Here is a compound where you can see that there are two hydrogens attached to this carbon. And replacing one of these hydrogens with deuterium is going to result in an asymmetrical center or chiral center. And therefore, these two hydrogens are said to be enantiotopic hydrogens. Okay. And when you look at this compound right here, you already have an asymmetric center. Right? Here is my asymmetric center. And these two hydrogens that is attached to this carbon are said to be the diastereotopic hydrogens, because when you replace either one of these hydrogens with deuterium, it's going to result in a pair of diastereomers.